Hi, my name is Frank and I work here at BU's ERC, also known as the Educational Resource Center. Today I just kind of wanted to show you guys how I think about functional groups and show you some tips and tricks to memorizing them so that when exam day comes, you guys won't be sitting there and thinking like, is it amine or is it amide? Is it ether or ester? Okay, so hopefully you guys can find something useful out of this. Okay, so to start off with, let's talk about alkanes, alkenes, and alkynes. So alkanes, alkenes, and alkynes. So well, alkanes basically are just carbons bonded to carbons, but with just a single bond. And then alkenes is just one step more complicated. They're just they're still carbons bonded to carbons, but now you have a double bond. And then for alkynes, they're just the next step more complicated. They're carbons triple bonded to each other. Okay, and on the exam, if they want me to differentiate between alkane, alkene, alkynes, and like let's say they had like a matching, and they gave me these three, and these three on the side. A trick that I thought of to remember them was looking at the A in alkane, the E in alkenes, and the Y in alkynes. So I just think of it as A comes first in the alphabet, so that must be the single bond. E comes next on the alphabet, so double bond. Y comes last on the alphabet, so it must be the triple bond. Okay, next is alcohol. So, alcohols. Now, alcohols might be one of the easier groups for you guys to remember because it's just a carbon chain with your OH. You guys have probably seen this in high school. But if not, just remember it as, a carbon chain, and then you have your oxygen bonded to a hydrogen. Okay, and next is the aldehyde. Now, the aldehyde functional group is basically just a carbon with an oxygen up here that's double bonded to. And just for future references, this is called a carbonyl, and this will come into your lessons in Orgo 2. So it's a good thing to remember. It's called carbonyl. And then, so aldehyde has a carbon bonded to an oxygen, and then a carbon chain to the left, and then you have a hydrogen right here, and that's it. So alcohol is just OH, aldehyde is just a carbon double bonded to O with a hydrogen and a carbon chain. And now we're going to go more complicated. So the next one that I think of is a carboxylic acid. So when it comes to carboxylic acids, I kind of think of it as a fusion between an alcohol and an aldehyde. So if I need to draw on the spot the structure, I just draw the alcohol functional group right here. And then I bring in the aldehyde component, which is the carbon double bonded to O and the carbon chain. So carbon double bonded to O. So do you see how I brought in the alcohol component and the aldehyde component? And that's your carboxylic acid. Okay. Now, to go more complicated, the next two that a lot of people get confused is amines and amides. So I'm going to show you the amine first. So the amine functional group is essentially just a nitrogen with a hydrogen, another hydrogen, and a carbon chain here. Now, amines, they can actually have carbon chains here and here as well, but this is just going to be one of the examples that I show you. So that's an amine. And a way you could think about it is amine, sort of like amino acids. They're the most simplest subunits of a protein. So amines, nice and simple, just a nitrogen bonded to a carbon and hydrogens. Next is the amide, or amide. So once again, I kind of go back to my aldehyde. So just like before, I'm going to draw the amine component down here. Nitrogen, hydrogen, hydrogen, and then let's see. And then once again, I bring back this component of the aldehyde. So here's my carbon, here's my double bonded O, and then here's my carbon chain. Okay, so that's alkanes, alkenes, alkynes, alcohols, aldehydes, carboxylic acid, amine, amides. So amines, they're simpler than amides. Okay, next, ethers and esters. Now, I got these confused when I first took oil. And then I realized it's not that bad. There's just little tricks they can use to differentiate the two. So for ether, when you think of ether, I kind of think of the word either or either. And the structure is basically an oxygen with carbons on either side. And then both of these carbons are just the carbon chain. It can change depending on different ethers, so you don't have to worry about that. And yeah, so on to the ether. So yeah, sorry, I know that might sound like really similar, but this is the ether, and then this is going to be a ester. Now the ester is just a little bit more complicated than ether. I do what I did before, and I bring in the ether. And then I bring in the aldehyde component again, excluding the H. But one small difference is this time, instead of bringing in the carbon, I use the carbon from the ether. There you go. So that's your ester. Okay. It's more complicated than the ether, and you can use the trick. Ether, like either on either side of the carbon. Okay, that's that. Let's see. Another one that, so we went over two functional groups with nitrogen before. Now I'm going to go over quickly a third one with nitrogen. And that's going to be nitriles. So nitriles are just a carbon, and you can look in the name of the functional group as tri. So when I see that, I immediately think of triple bond. So carbon, triple bond to the end. And then sometimes it's just written as this, and they simplify it. But the moment you see a CN, just know to yourself immediately, it's going to be a carbon, triple bond to an N. Okay? Let's see, what else am I missing? And then there is, thiols. So thiols are basically the same thing as alcohols, but you have a sulfur instead of the oxygen atom. And they both end the same way, so maybe that'll help you think of the structure. Thiol, and then there is thiol ethers. Thiol ether. sometimes your professor might call them just sulfides. Okay, so thiol ethers are, once again, when you see ether, think of either. So you'll come back to this structure. But now, because there's a thiol here, like before, you switch the O with an S. And then you keep your carbon chain. And that's a thiol ether. Okay? So, let's see, what else did I want to go over? Oh, the last thing. The last thing is arenes. So arenes, when I see the word arene, I just think of a ring. And that's basically what they are. They're just rings, but they have double bonds inside. So like this benzene. And a trick you can use to remember arenes is that they have double bonds, so they have the ene part in their name, like alkenes. So you could kind of think of it like a ring of alkenes. So it's basically an alkene here, alkene here, alkene here. Okay? I hope that helps you. If you guys have anything else that you'd like me to try to explain, feel free to post a comment or something. If you have any criticisms, suggestions, feel free to tell me. Yeah, alright, good luck. Okay, if you like what you just saw and found this helpful and you want more, feel free to check out the ERC's website, or you could just come by the ERC. We're on the 5th and 6th floors of 100 Bay State Road. There are a bunch of other orgo tutors like me who can help you out with any other questions that you have. We also have other tutors for Chem, which I know is a really, really frustrating topic. I also tutor that too. It's a lot of fun tutoring it again and helping you guys out. So yeah, check us out. Good luck.